In Lesson 11, we're going to look at ratios of fractions and their unit rates. Example 1 talks about Izzy, who can run 202 1/4 miles in 15 minutes, and her friend Julia, who ran 3 3/4 miles in 25 minutes. Each girl thought they were the faster runner. So based on their last run, which girl is correct? We're going to take Izzy and Julia's rates and we're going to transfer them into tables to see what we get when we extend their rates. So then in our tables, we'll start off with the initial values. Izzy went 2 1/4 miles in 15 minutes. So we have 15 minutes, 2 1/4 miles. If we translate the time into hours, and we're doing that because we want to be able to compare in miles per hour as well. 15 minutes is 1/4 of an hour. Then we could extend that. If she is running for 30 minutes, that would be a half an hour, and she would go 4 1/2 miles. We're simply doubling the numbers. If she were to go 45 minutes, we would be tripling the numbers. That would be 3/4 of an hour and 6 3/4. If she went for 60 minutes, that is 1 hour, which should show us a unit rate, and that is 9 miles. And we can extend it one more to 75 minutes, which is 1 1/4 hours, and she can go 11 1/4 miles during that time. Julie, on the other hand, went 25 minutes, which is 25/60ths, or simplified would be 5/12ths of an hour, and her distance is 3 3/4 miles. So if we double that, we would get 50 minutes, which again is 50/60ths of an hour, or 5/6 of an hour. And her distance there would be 7 1/2 miles. Extending it a little bit further, if she went 75 minutes, and you'll notice the 75 minutes does match in Izzy's table above, 75 minutes would be 1 1/4 hours, simplified. And she can go 11 1/4 miles at that time. Finally, if we extend Julia's table one more, we could go to 100 minutes, which is 1 2/3 of an hour, and she can travel 15 miles in that amount of time. So then if we look back and compare the tables, we can see that Julia went further, so this means that she ran faster. Or is that the case? Julia's times are somewhat longer, so we can't just compare the number in the table. We actually need to compare the same units. So if we were to take a look at the constant of proportionality, we could do some division to find out that the unit rate would be 9, or our constant of proportionality would be 9. And the same thing is true for Julia's. So actually, Julia and Izzy are traveling at the same rate. We can also see that when we look at the 75-minute mark, both girls have 75 in their table, which is 1 1/4 hours. And if we look over at the distance that they ran, we see that the number is the same, 11 1/4 for Izzy, 11 1/4 for Julia. And so in that way, our table tells us that they have the same rate. Let's take a look at exercise 1, where it tells us that a turtle walks 7/8 of a mile in 50 minutes. And we are looking for the unit rate expressed in miles per hour. So to find the turtle's unit rate, Meredith wrote and simplified this following complex fraction. A complex fraction is just another way to show division of fractions. Please keep that in mind. So they want us to find out how the fraction 5/6 was obtained. Julia chose 7/8 divided by 5/6. The 5/6, since 7/8 is 7/8 of a mile, the 5/6 must be related to the minutes. There are 60 minutes in 1 hour, so we could be talking about a ratio of 50 to 60 minutes, which could be simplified to 5/6. I think we found where that 5/6 came from. The second part of the question is, did Meredith simplify this complex fraction correctly? Now, this may not be the method that you would choose, but looking at it, we can see that she multiplied by 24, which seems to be how she would like to get rid of the denominators in these two parts of the complex fraction. She found that 8 goes into 24 3 times, and 6 goes into 24 4 times, in which case she would then have to multiply the numerator times that factor. 7 times 3 is 21. Same thing in the bottom part of our fraction, 5 times 4 equals 20. And so in that way we can see that she seems to have simplified that complex fraction correctly. Even if that's not the method that you would choose, hopefully you can follow that math. Question number 2 talks about Anthony's birthday, and Anthony's mother is making cupcakes for his 12 friends at his daycare. The recipe is calling for 3 1/2 cups of flour, and the recipe makes 2 1/2 dozen cookies. Anthony's mother has only 1 cup of flour, however. So we need to determine whether that's enough flour for each of his friends to get a cupcake. So in this situation, we're looking at 3 1/3 cups of flour that makes 2 1/2 dozen cookies. So we're going to set it up as 3 1/3 3 1/3 divided by 2 1/2. And if we change those mixed numbers into improper fractions, we would get 10/3. 10/3 divided by 5/2. And then following our rules of division of fractions, we would turn that into 10/3 times 2/5, which is the reciprocal of 5/2. Multiplying straight across, we would get 20/15, which simplified would be 1 5/15, or 1 1/3. So that number translated would be 1 1/3 cups of flour per dozen cookies. Cupcakes. In which case we can see that if Anthony's mother only has 1 cup of flour, she does not have enough flour for each of his friends to get a cupcake. In problem number 3, Sally's making a painting where she's mixing red paint and blue paint, and the table shows the different mixtures that are being used. To find the unit rates for the values, we need to divide the blue paint by the red paint. So to find our unit rate, we would divide 2 1/2 by 1 1/2. When we convert those mixed numbers into improper fractions, we would get 5 halves divided by 3 halves. And then we need to rewrite the problem as a multiplication problem using the reciprocal of the second fraction. And finally, when we finish that, we would find 5/3 or 1 2/3 to be the unit rate for the values. To determine whether the blue paint is proportional to the amount of red paint, we would double check the rate from other numbers, and we do find that it is proportional. Finally, in the context of this problem, we would describe in words for every 1 2/3 quarts of blue paint, she must use 1 quart of red paint.